Rendering out in Karma is pretty simple. All we do is set down a Karma node, and what we do from here is specify where we want this to go and then render to disk. That's pretty much it. So here in the output picture, I'm going to say hip. Again, that's where we saved our scene file. Let's go to our render folder. Let's call this our VV render version 1. And then for the file name, we need to say a few things. So let's call this our VV render version 1. And then I'll say $f4.exr. When I said $f4 right there, what I was saying is take the frame number and give us a padding of 4 digits. So what that basically means is that when this goes out to save, it's going to be 0001, 0002, and so on. It's just standard convention to do it that way. So that's why we say $f4. F for frame, 4 digits of padding. On the resolution, it's most common to render this out in full HD, 1920 by 1080, right there. If you are using Apprentice, you might be limited to 1280 by 720 though. So that is the standard 16 by 9 aspect ratio for film. Rendering engine, we are using CPU. And for right now, at the top, let's just render the current frame and see what happens. So I'll say render to disk. And the minute I do that, what happened? Well, we don't have a dialog popping up or anything. It looks like nothing happened, but if we go up to the render and we click on this scheduler right here, we can actually see the progress happen. So right now we have about 19 seconds that have elapsed. Let's go find our folder real quick. So we'll go back to our render, VV render 001. Nothing's in there yet, but when this gets done, we should see an EXR file right there. Once we have this guy, let's head on over to our image context right here. Let's go ahead and make a new image network. And we are going to set a file node right there. If we browse, we can find our file right there. And then we head on over to the composite view up top. So there is VV. Now, he's a little bit grainy right now. If we zoom in, I can just middle pan, right zoom, right? We do have some grain down there. So if we need to increase the quality of our render, let me show you a simple way of going about this. Head on back to the stage, select the Karma node, and I'm going to set the pixel samples here to 2048. That's not a bad place to start when you're trying to make a clean image. Everything else is pretty much at the default. I did turn up the light sampling quality a little bit because we have that distant light wrapping around VV. So I turned that up to 3. And then if we go to the Advanced tab, you then want to go to Sampling and take this noise level to 0.0075 or 005. To explain what this is all doing, it's going to take a little bit of time, so I'm going to not get into that right now. I think we've already made things complicated enough in this course. So for right now, just take my word for it that this is a good place to start. And the main control for increasing the quality here is in the pixel samples. So again, we are doing that with 2048. After we do that, let me show you what that does. So I'll head back to the image context. Let me find a frame that is cleaner. So right here. This is what that will give us. So that really cleans up a lot of that noise. There's still a little bit right there, so you can always add more samples if you'd like, or take down that variance threshold. And well, that's pretty much all you do to render. All right, so we have our scene. It's basically done. It's good to go. Now, for the fun part, let's play around with some different effects on this orb. I'm going to show you how easy it is to get up and running with various effects. I'm going to do some kind of effect myself, and then I want you to go off and experiment with your own effect for the sphere. So what we have so far is VV and the sphere that's merged in. However, what I'd like to do instead is detach this wire. Hold down Y on the keyboard. That'll bring up these scissors, and we can cut the wire right there. Now, after the mountain, I'm going to create a null. This null node doesn't do anything, but it's really useful for making it easy to browse for a certain part of your network. You see, if I call this out_orb, I can then create a brand new network that is going to be called our orb_effects, or orb source actually is probably a better name for that. Then I'm going to create an object merge. So we are merging in one of our objects here. All right. We'll then look for our VVGeo, and that null is going to show up at the top right here as out_orb. So there we go. We brought that into a separate network. Now, at the top here, we have all kinds of different shelf tools. And these shelf tools are going to create different presets. So I'll give you a good example just real fast. Let's say that I have this orb object highlighted or selected. If I go towards the top, we have our shelf, which is basically a collection of presets. So under this Vellum tab, I'm going to turn our sphere into a Vellum cloth. Go ahead and click that, and as soon as I do that, it made all kinds of nodes. So going back to the object level, we have our auto-dop network right here, our cloth Vellum, and our original orb source is here as well, but it was turned off. If you'd like to simplify what happens with any simulation, think about three things: source, force, solve. In this case, our source is the orb. So if we go to our orb source, we start with this. It's kind of like the initial ingredients that we have to work with. The second stage, force, is all the attributes that we put on that sphere. Again, attributes describe something about an object, so we are describing various things about the sphere that the Vellum solver is going to understand. That's what's happening here with the Vellum constraints. If we middle mouse click, we can have all kinds of different attributes being generated right here. The drag normal, drag tangent, mass, position, p-scale, velocity, all kinds of stuff has been added to our sphere so that we can tell the solver what it should do. And we also have another thing coming out of the second inputs. These are the actual constraints with the compression stiffness, the constraint tag, the dampening ratio, all kinds of stuff that again will control the result that we get. So once we have our source, we have our forces modified, it then goes here to the auto-dop network. So this picks up those ingredients, and we'll talk more about the specifics of how a auto-dop network works in the next course. But in general, just think about it as we grab stuff from SOPs, we're putting it all together, and eventually it all goes here to the Vellum solver. That's the third stage, solve. So we take all these ingredients, we run it through all kinds of calculations, the attributes tell the solver what to do, and we collect our results here in this cloth Vellum network at the very end. So here we import the DOP network, and then we clean up the geometry, and that becomes our final result. Let's go ahead and just go forward a few frames and see what happens. Right now, we just have a falling orb, but if we go here to the auto-dop, we can just add a ground plane real fast and set that underneath the solver. So we end up with something right there, and you'll notice that this bar down here turned orange. That means that we need to reset our simulation to see the new result. So when we click on this button down here to go back to our beginning frame, we've now cleared that out. We now have the ground plane, and we have cloth, like this. So that is the essence of how simulations work. And it doesn't matter if it's a cloth simulation, a pyro simulation, a water simulation, they all go through those three phases: sources, force, solve. So source, force, solve. That'll help you if you are trying to wrap your head around simulations right now. I also want to point out that you didn't have to know anything about the Vellum Solver to get something cool going. So yes, you want to eventually understand all the details and what every single attribute does and how to make things custom. But to get you started as a beginner, all you really need to do is figure out how to get from A to B. So how to get to your goals. That's really all that matters here at first. So the nice thing is that Houdini does offer you a way of doing that, and it's why it's worth checking out these shelf tools. In the next video, let's move on by talking about a couple more things, and then I'll leave you with some concluding thoughts.